Question 6 here, 500 kilogram car is traveling at a constant speed of 16 meters per second and a radius of 40 meters. So it says I draw arrows for velocity, acceleration, force. So the centripetal force is in this direction. The centripetal acceleration is in this direction. And the velocity is in this direction here. And that's just like your tangential velocity. Find the acceleration of the car and the force on the car. So for Newton's laws, again for circular motion, it's just F equals ma. So I'll do both of these in one step here. So the mass of the car is 500 kilograms multiplied by, we've got v squared, so 16 squared over a radius of 40 meters. And that gives us a total force of 3,200 newtons. And that's, again, centripetal force, which is actually, in this case, the friction. If I wanted just acceleration, it would be this here. Okay, this one here, rocket swung in a circle at the end of a string. What will happen, the acceleration of the rock, if the length of the string is doubled and the speed of the rock is doubled. So, again, looking at this equation here, acceleration centripetal is equal to v squared over the radius. So these two right here have an inverse relationship. So if one goes up, the other goes down. So centripetal acceleration is equal to 1 over the radius. It's proportional to that. So if I said 2 times the radius, then I would get a proportional change to the centripetal acceleration. So twice the radius would give me half the acceleration. If the speed is doubled, then centripetal acceleration has this relationship with the velocity. If you square the velocity, if you double the velocity, then it's going to be 4 times what the acceleration is. So it would be 4 times centripetal acceleration. Question 8 here, it says, what is the minimum coefficient of friction to keep a car of mass m traveling in a circle with a radius of 30 meters at 12 meters per second? So velocity is 12 meters per second. 30 meters is the radius. And m is the mass, which we're going to find out actually cancels out in the problem, and we're looking for mu. So if we look at our equation, the minimum coefficient of friction, again, that's going to be force centripetal. In this case is actually mu mg. Right? So that just tells us that mu mg is actually the force of friction. So friction equals mu mg. And it's just the positive version of the normal force, because we know that friction is actually mu times normal when we're talking about Newton's laws in like linear motion, straight line motion. So for us, we're going to write down centripetal acceleration, which is mu mg, is equal to m v squared over the radius. The masses cancel out, and then we end up with mu g equals v squared over the radius. And so I end up with mu is unknown. We know gravitational acceleration is 10 meters per second squared times mu equals 12 squared is 144 over radius of 40 meters, 30 meters. So if I do the math out here, I end up getting a coefficient of 0.48. For this problem here, it says, what is the force of gravity between the Earth and a 200 kilogram satellite located 500,000 meters above the surface of the Earth? The radius of the Earth is this here. So you need to be careful with this one, because the equation for force of gravity is gmm over r squared. And so m1, m2 over r squared. So for this here, the radius is going to be adding these two numbers up. And I'm not going to do this from beginning to end because this is a pretty easy problem, but it would be 6.4 times 10 to the 6th plus 500,000. So it's 1, 2, 3, 4, 5. Times 10 to the 5th. I'm going to square that, and that's going to go in here as r squared. And then I put the corresponding masses here, which above the mass is 6 times 10 to the 24th. So this mass would be 6 times 10 to the 24th, and then the mass of the satellite, which is 200 kilograms. And g is that 6.67 times 10 to the negative 11th. And again, just be careful with your exponents here. And if you do all this math out, you should get something like 1.16 times 10 to the 10th. and that is newtons. Now, for this question here, what is the force of gravity on a mass of a surface? Actually, skip that. This one right here, 12. 12 is, what must the speed of a satellite be, which is in orbit, the Earth at a distance of 4 times 10 to the 7th meters above the center of the Earth. So we're looking for velocity here. Now, here's the problem. We don't have the mass of the satellite. And so I should tell you that it's probably irrelevant. So what happens here is we're going to take two equations and combine them, because that object is actually accelerating. So it's this equation to figure out what the behavior of the satellite is. And then we know that the force of gravity is equal to gmm over r squared. And so what we'll do is we'll substitute this piece right here for this guy here. So we'll end up with mv squared over r equals gmm over r squared. Now, algebraically, how this works out is one of our masses cancels out, and then one of our, we've got a radius here, we've got radius squared. So what we end up with is this is gone, and this is gone. And we end up with v squared over r equals gm over r. And, oops, I made a mistake there, over 1. So what that simplifies out to is velocity of a satellite is gm over r, square root of that. So the mass of the actual object that's orbiting the Earth is irrelevant. So if I substitute the numbers in here, just be careful with the distance. It's above the center of the Earth, so we've got to add this number here plus this number here, and that would go in as the radius. The mass would be the mass of the Earth, and g is, again, 6.67 times 10 to the negative 11th. Number 17 here, the coefficient of friction on a curve around a track is 0.5, and the radius of that turn is 50 meters. What is the maximum speed the car can take around the curve without slipping? So we're looking for velocity here. Now, the mass is also unknown, and again, it's irrelevant in this situation. So we end up with centripetal force is equal to mv squared over r. We also know that the force in this case is a frictional force, and that's mu times mg. So again, like the one we did a little bit earlier, we end up with this equation here. So we rearrange this equation, we get rid of the mass first, and we end up with mu g equals v squared over r. So if I sub in my values, I get 0.5 multiplied by 10 meters per second squared, which is circular motion, so we don't make that negative or positive, we just leave it positive. And then that equals v squared over the radius of 50 meters. Multiply this, you get 5 is equal to v squared over 50. Multiply both sides by 50, and then multiply both sides by 50, and we get 250 equals v squared, and the square root of that is 15.81 meters per second. So we'll do number 27 here. Again, the mass here is 0.2 kilograms for the rock. It's swung over your head, or swung around a radius of 0.75 meters. If the tension of the string is 10 newtons, what is the velocity of the rock? So again, we're going to take this equation here. This is an object, again, it's turning. It's always turning. It's going in a circle, so we know it's accelerating. So if it accelerates, then we know it's an F net equation. So F equals ma. So we know that centripetal force is equal to mass times the velocity squared over r. So we know the tension here is actually what's causing it to swing in the circle. Now, the sort of deceiving piece here is that we assume it's going this way. If it's vertical, that changes everything. So, or it could change things. So, for this, in this particular situation, at that instant, it's 10 newtons. So it's 10 newtons equals, and my mass is 0.2, not 2 kilograms, and then the velocity of the rock is the unknown. I'm writing 12. So the velocity is unknown, and the radius that you swing this is 0.75. So again, just manipulate this. So we take both sides. Actually, we can do this side of the equation first. So we end up with 10. Oops. Multiply both sides by 0.75. We get 10. Actually, we don't. We get 1.5 equals 10 equals 1.5 v squared. Divide both sides by 1.5. to get 6.67 meters per second.